Hey, hi everyone. Welcome to the first live session of this NPTEL course Design of Reinforced Concrete Structure. And I am Sanjay Kumawat, the PhD student at IIT Bombay, and I would be taking all the live sessions for this course. So, today, what we are going to discuss is the assignment zero. So, the assignment zero has a total of 10 questions. So, let's look at them one by one. So firstly, I will be displaying you all the questions, and then you are required to think upon it and guess a right answer. So this will be the way how we will be conducting the live session. So the first question for this assignment is the maximum bending moment occurs for a cantilever beam under UDL at. So this is a very simple question, I think. So this assignment zero is basically for practicing purpose. So here you can see the cantilever beam with a UDL load. So when we draw the bending moment diagram, so this is the bending moment diagram, and bending moment, it can be easily calculated. Like we can calculate the load upon this by multiplying this W by L, and that will be acting at the center, and the moment can be taken easily, and it is found that the maximum bending moment, it occurs at the support. So this was a very easy question. Now the next question is, where does the maximum shear force occurs for this same cantilever beam which is subjected to UDL? So similarly, what we can do, we can like draw the SFD, and here also it is very easy that the maximum shear force would be occurring at the support only. So now let's look at some more good questions. So the third question is, the minimum grade for PCC and RCC structures as per IS code is. So as per IS code, you will be like introducing to some IS codes during this NPTEL course of Design of Reinforced Concrete Structures. So the main IS code, or the frequently used IS code for this code, is IS 456. And according to IS 456, what we have is, we have the minimum and maximum grade of concrete which we should use under different exposure conditions. It is mentioned in this IS codes, IS 456 2000. So IS codes, what they are basically design guidelines which we are supposed to use. These design guidelines, they are like based upon years of research. They are prepared and they are updated uh, every year, or what should I say, they are updated frequently. Not every year, but they are updated frequently. So according to this IS code, the minimum grade of concrete which we should use for PCC and RCC. So PCC is plain cement concrete and RCC is reinforced concrete. So for PCC, the minimum grade of concrete which is suggested by this IS 456 is M15, and for reinforced concrete it is M20. So the correct answer would be what? It would be M15 for PCC and M20 for RCC. So also I have like displayed what are the different exposure condition. What does this exposure conditions means? All of these are mentioned in different tables of IS 456. So basically you can read it out here. You can pause the video and read it. So the correct answer for this question is answer C, M15 for PCC and M20 for RCC. So now let's look at the fourth question. So the fourth question, what it asks is, the compressive strength of 100 cube as compared to 150 cube is always less, more, equal, or none of the above. So this is a bit of like a question which you should think upon. So basically, I can answer you this question in two formats. That is, I can give you reasons for the answer of this question in two ways. So the first reason would be in a physical manner. So a smaller size cube will have fewer number of whites, and at the same time it will be having parent geometry more closer to it, and it will be having good bonding. So by physically, what we can say, that the compressive strength of 100 cube, it will be more as compared to 150 cube. The other reason what we can give is mathematically. So mathematically we know that the compressive stress is force by area. So let's take the force as 1 kilonewton. So when we calculate the compressive strength for 100 cube, it comes out to be zero point 0.1 MPa, whereas for 150 cube, it comes out to be 0.04 MPa. So it can be seen here that 100 cube, it has higher compressive strength as compared to the 150 cube. So we know that high stress means it have a high internal resistance, that means it is having higher strength. So from both of these reasons, what we understand is 100 cube will be having more strength as compared to the 150 cube. So now let's look at the other question. The fifth one is, under a transverse downward load on a simply supported beam, the tension will be where? So this is also a very simple question. So I think we have studied in the lower standards, like when a simply supported beam it is subjected to a central transverse load, it will be having tension at the downward side or at the bottom side and a compression at the top. Whereas in a cantilever beam, we will have compression at the bottom and tension at the top. So the correct answer for this is the tension will be below the neutral axis. So now the sixth question is, which of the following stress can plain cement concrete endure? So plain cement concrete, it basically what does it means, the plain cement concrete does not have any reinforcement to take any tension. So the only stress which a plain cement concrete can take is basically compressive strength. So you can see here, this is unreinforced concrete beam and it got failed in the tension region. So the only stress it can take is the compressive strength, and the shear stress also it cannot take, because shear stress is basically associated with cracks. So for those cracks again we need reinforcement so that the cracks do not elongate. So basically shear stress can also not be handled by the plain cement concrete. So again we have a compressive stress for this. Now the seventh question is, if the slump of a concrete mix is 60 its vocabulary is. So let me first remind you what is slump. So in order to check the workability of concrete, we have a slump cone test. We feel the concrete inside this slump cone test in a particular manner, and what are those particular manner are mentioned in some IS codes. We should feel the concrete inside this slump cone and we should remove it slowly. Then the slump is the measurement of the height of the concrete from the top of the slump cone, as it can be seen here. So, based upon the height of the slump cone, its workability can be classified into low, medium, and high. And the criteria for this workability classification is based upon the height of slump, which is mentioned in the IS code 456-2000. So, here we have for different height of slump, the degree of workability low, medium, and high. So, for this question, the correct answer would be medium from this table. Now, moving on to the question 8, how many layers of concrete are needed to fill a slum cone? So, to carry out a slum cone test for finding out the workability of a concrete, we need to follow some IS codes. So, IS 119 2018, it gives the procedure of carrying out the slum cone test. So, what does it says? It says like we should fill the concrete in different layers, so it should be filled in three layers of the height of mold. So the correct answer for this question is B, three equal layers by height. Now coming on to the ninth question, unit weight of cement is. So unit weight of cement, again this is mentioned in IS codes. So IS 875, we have different parts of IS 875. Part 1 is for the calculation of dead loads, part 2 is for calculation of live loads, part 3 is for wind load, 4 is for snow load, and part 5 is for combination and for special types of loads. So cement is a type of dead load, so we can get the unit weight of cement in IS 875 part 1 1987. So here it can be seen that the cement it has a unit weight of 1440 kg per meter cube. So the final question for this assignment is, what is the compressive strength of a 50 centimeter cube after 28 days for M15 concrete? So this is also a question which we have studied a lot of time. So basically we know that for different grades of concrete, M15, the number which is after M, it mentions the compressive strength in megapascal. So it will be having 15 megapascal. Also, the different grades of concrete and their compressive strength has been mentioned in a table in IS 456-2000. So here it can be seen for N15 we have 15 Newton per mm square of strength, and when we convert this into kg per centimeter square, what we get is 150 kg per centimeter square. So this was all about today's session. Now we will be meeting for our next session on Tuesday from 6 to 7 p.m. Thank you.